Hello, I am Muskan from Cheenta. Today we'll be solving a question from IIT JAM 2021, problem number 53. Let x1 and x2 be independent normal random variables. Define SGN, also known as signum function of u, as -1 if u is negative, 0 if u is equal to 0, and 1 if u is positive. Further, let y1 is equal to x1 times signum function of x2 and y2 is equal to x2 times signum function of x1. If the correlation coefficient between y1 and y2 is given as alpha, we have to find the value of pi alpha. In order to find the correlation coefficient between y1 and y2, we must know the probability distributions of y1 and y2. Let's figure out that. y1 is equal to x1 times signum function of x2. That means this thing, signum function of x2, will take value -1 when x2 is negative and 1 if x2 is positive. So it is simply multiplying 1 with x1 when x2 is positive and -1 with x1 when x2 is negative. Also, since x2 is a standard normal variable, the probability of both these cases is equal and given by 1/2 each. So from here, we can verify that y1 follows standard normal variable. This can also be verified by the formula probability of y1 less than y is equal to probability of y1 less than equal to y given x2 is positive into probability that x2 is positive plus probability of y1 less than equal to y given x2 is negative into probability of x2 is negative. Similarly, y2 also follows standard normal distribution. Now, the correlation coefficient between y1 and y2 is given as alpha is equal to expectation of y1 y2 minus expectation of y1 into expectation of y2. Let's figure out both these values. y1 into y2. Let's figure out what is this. y1 is given as x1 times signum of x2 and y2 is given as x2 times signum of x1. So these values are x1, x2 into signum of x1 to signum of x2. What are these values? Let's figure out. If x1 and x2 both are positive, it will be equal to x1, x2. If both x1 is positive and x2 is positive. Similarly, when both are negative, again -1 into -1 will give us positive 1. And if both of these values are different, that means x1 is negative and x2 is positive, or the other way around, this value will be negative. Minus x1, x2. Now, taking expectation on both sides, we have to find the expectation of all these quadrants. Also, one thing, that all these probabilities are equal. So we can assume that this is 1 by 4, 1 by 4, 1 by 4, 1 by 4. And expectation of x1, x2 can be calculated using double integration. That would be given by given x1 is positive and x2 is positive into probability that x1 is positive. X2 is positive. Since all these probabilities will be equal, we can just multiply it by 4. So this will be given as double integration from 0 to infinity of x1, x2 to e to the power of minus 1 by 2 x1 square plus x2 square to dx1 to dx2. Solving this double integral, we'll get the value 1 by 2 pi. So following the symmetry, all these expectations will be equal to 1 by 2 pi, 1 by 2 pi, 1 by 2 pi. And so the expectation of y1, y2 is equal to 4 times 1 by 2 pi. That is equal to 2 by pi. Now, correlation coefficient alpha is equal to 2 pi minus this will be 0. So, the value of pi alpha is equal to 2. That's what asked in the question. That is equal to 2.